the isometric view. So isometric means, for example, you have finished recently pyramid. So for example, if you take, there is a one, what is this? What is the name of the object? Fully square pyramid. It is a square pyramid. So is it a 2D or 3D? Is it 2D or 3D? 3D. So is it an isometric or orthographic? Isometric object. It is an isometric. Okay. So you have to convert from iso to ortho. What you have did? You have converted from iso to ortho. So first we have seen the object from their front view, and you have observed this. You can see very clearly in their front view. Okay, whatever I am hatching here, that you can see in the front view, and you have represent the views very clearly on the XY line. This become your front view. And similarly, if you are looking from the object from the top, same, you have constructed the object in the top view. Okay, so from iso to orthographic. Okay, so this is the method you have followed in the previous lesson. Okay, so now you are studying the isometric, means from 2-dimensional to 3-dimensional. మీ దగ్గర ఇప్పుడు ఏముంటుంది? వ్యూస్ ఉంటుంది. Object views you will have. Any type of object it may be. Any. Okay. So that views you are visualizing and you are completing their 3-dimensional. Okay. So how to construct this pyramid? What are the different methods? Because if you are seeing these orthographic, here you will have the actual scale. Actual scale and you have measured with the correct units. Whatever the height, that is as per your scale, and their width, sides, everything is actual. Okay, but in orthographic, it is not the actual one. Okay, it is looking like a one object from their views. For example, if you are observing in the front view, can you measure this front view from your visual? No, you cannot mention. You know only the shape. Okay, or simply by measuring this length, it cannot be actual. Okay, so you have to convert the actual scale. There is a one scale conversion. Okay, so from actual to iso scale you have to convert. Okay, so any doubt here how to convert from iso to ortho and ortho to iso? Okay, right. Which example do you want to take in the first? I will draw their views and you have to convert the iso. Which example do you want to take? Any example you can take. Hexagonal prism. Okay, so hexagonal prism, what we have done, just example, there is a one XY line, we have represent VP, HP, hexagonal. Okay, whatever the location of the hexagonal, either it may touches edges to HP or corner to HP, any one I will draw. This will be your question in the examination. This diagram will be given. That becomes your question. Okay, so hexagonal, you are talking about prism. Okay, so there will be base for the prism and this is an height. Let us write the numbering A, B, C, D, E, F. These are the top numbering I will represent. Like here, A dash, B dash, C dash, D dash. In the bracket, there will be E dash, F dash. Right? This is the method you followed. And in the bottom surface, I will represent this type you have followed. Okay. So here 1 dash, 2 dash, in bracket 6 dash, 3 dash, 5 dash, 4 dash. So this is your question now. In the examination, it will be ask you to draw the isometric projection of the given figure. Okay. Given figure can be anything. You know only isometric and prism and pyramid. But the object can be anything. Any metal you take, anything you can take. It may be textbook or any object. Ippudu mana workshop lo any object you are cutting, right? Okay. It may be lap joint, butt joint, or if you are doing in the fitting section, whatever their section, that object, their views will be given. Their top view, front view will be given. From that, you have to draw the object. Views will be given. You have drawn the different views, right? So that view will be given. So from here, now there is a hexagonal prism having a dimensions. I will write the some dimensions. I will take this as 50 and the sides of hexagonal, let us take 25 or 20. Okay, clear? The question is clear to you? This become your question in the examination. Now you have to convert this object into ISO like this. Okay. So as I said you, these are the actual dimension. Actual means same. Whatever the scale you are having, all are in meter, millimeter, meter, centimeter. So they are in the actual scale. Now don't copy these questions like size in your drawing. Okay, so you have to draw first, because in your question paper they may be given approximate sizes. 50 mm is not there. Okay, you have to draw again. Whatever the question you are seeing in the paper, that you have to again draw with your actual scale. That you can do by taking height as 50, making the hexagonal with a sides of 20 mm. You have to construct once again with this dimension. Okay, means copying just with actual scale. Okay, so after that there is a one scale conversion, that is ISO scale. ISO scale. Okay, so take one vertical line, horizontal line. Okay, O. Now take an angle of one is 30 degree, one inclined angle, and another inclined angle is 45 degree. One is 30 degree, another is 45 degree, two inclined line. Okay, so the inclined line of having 45 degree, it will be your actual scale. Actual scale means take the scale. Okay, take the scale. Anybody having separate scale? So this is your actual scale now. Okay, so just keep on this scale whatever the maximum dimension in your diagram. What is the maximum dimension? 20, 50 mm. So up to 50. Okay, up to 50 means you can take 60, 70, it is not a problem, but what is the maximum? What is the maximum value in your diagram? 50. So I start with 10 mm first. This is 10 mm, 20, 30, 40, 50 up to here. This is 50 mm. Okay, 5 centimeter. Okay, so I will take this is as 10 mm, 20, 30, 40, 50, 60 like that. This is maximum. So this is 10 mm, 20 mm, 30, 40, 50, 60. All are millimeter, remember, because in your diagram given in millimeter. Okay, if it is given in centimeter, take as centimeter. Okay, so after that, this is the actual scale, no changes in this, just the scale you are keeping and mentioning there. After that, from this point, whatever the mark you have made, from that point, take a 90-degree line to this point, to this line. It should touch us. Straight line, 90-degree. Okay. So now this become your ISO scale. Which one? This is your ISO scale. Got it? So this 10 you have to take in your diagram now. Okay, forget about this. If you want to draw 50 mm, take this 50. This is your ISO scale. Okay, so any doubt in the ISO scale now? Okay, so after that we have to construct 3D object now. Okay, isometric object. Draw one horizontal line with thin lines. Okay, make two inclination line having 30 degree. Somewhere draw one horizontal line and you should have the distance, approximate distance 50 mm at what height it can. Okay, it should not go beyond. So you have find one point on the horizontal line, make two inclination line 30 degree, 30 degree. Okay, 30 degree, 30 degree both sides. After that, I want to transfer this hexagonal, because just imagine it is an hexagonal prism, base having hexagonal, top having hexagonal, base also having. So first I want to transfer the base. Okay, first I have to transfer this base on my hexagonal stand, yeah, on the isometric stand. This is like a stand here. Okay, so we have to transfer the base first. So here this hexagonal I cannot shift because only two bases are there. Only two bases. But here there are different bases are there. So for this type of complication, the easiest way is to make the box, as you already know, make one rectangular box like this, all element within that box. Okay, let us mention 1, 2, 3, 4. This you can do. Okay, because you have already followed in the VP, inclination of VP. Okay, everything is in the rectangular, all elements. Okay, so now let us say 192. Either 192 on this side or this side, anywhere you can turn. 192. Okay, so measure this scale. Measure this scale. This is what it is, your actual scale here. So measure that with your compass. I know this is 20 and that is in the ISO scale 20, but I have not measured this one. Okay, so that you take with compass whatever the distance in actual scale. Measure that and keep on the actual scale. Measure this one. For example, it may be approximately 30-35. Okay, so maybe here that distance. If you measure this, okay, same thing. Look at here. This becomes your actual scale. I convert that is into ISO scale because that is not our calculation. That is not our actual dimension. That is just To transfer that hexagonal we are using. So this distance I got. Again take this is as your isoscale. So whatever you are doing in this area, everything should be isoscale. The convert is required everywhere. Okay. Now you take this distance and mark on any one side, whichever side you want. Okay. So for example, that distance I will mark on this. Okay. So of course, same side will be there in the bottom also. So now this is, if you say this is as 1 to 2 and another side become 1 to 4. 1 to 3. Another side will be this one, 1 to 4. One is 1 to 2. So this will be different of course. So again you take 1 to 4 distance. It may be lesser than that. Again take the ISO. So you have to draw here 1 to 4. Okay. So now same distance 1 to 2. From if you keep here on 4, draw same parallel line because that is both will be same. Okay. And take the diagonal now. 1 to 3 if you take the diagonal distance, convert here, then you will get this second point, like shifting the your rectangular here. Can you do this? Just because you are getting confusion because I am making this as rectangular. Okay. If it is square, then it is easy. It is a hexagonal, right? We are making first 1, 2, 3, 4. So 1, 2, 3, 4 is transferred here. 1, 2, 3 is here, 4. So now what is there between 1 and 2? Between 1 and 2, there is 1, F and D. So take this distance. Again convert. Again draw on this. You have to take only actual scale here. Converting, taking. Same thing, 3 to 4. Again 3 to 4. On 1 to B there is a FE. Now 3 to 4, 3 to 4 B and BC. Yeah. Same distance you will get. BC. Now what is there between 1 to 4? 1 to 4 there is a. Again convert, find this distance. Now what is there between 2 to 3? So here this is A, B, C, D and here it will change E, F. Like this you will get. Hexagonal base you are getting. Okay. Make thick line. Did you got the base? Hexagonal base. After that you have to find the center. Find the center for the hexagonal. So this become your center. The axis. Okay. So from the axis what is the height? From the axis what will be the height now? 50 mm. So take this 50. ISO 50. You have to take ISO 50. Put at the center. Height is 50. Okay. From all the corners the height 50 you have to take. All the corners. So I may be getting approximately 50, but you have to take the actual one. Like this. All heights, all curves are getting at a height of 50. Okay. Now all the corners take a straight line. F you have not taken. What is this? Like this. Okay. So again in the top also you will get hexagonal. If you join all this. So now E2, E is here, Yeah, E is here. E to F, F to A. A may be somewhere here. A to B, B to C, C to D, D to, like that, same shape. So in the top you have mentioned 1, 2, 3, 4, 5, 6. Make it thick line. Got it? So now your all faces you can see very clearly. So this is your first face, second face, third face, and this become your top face. Okay? Hexagonal. Okay, so this becomes from 2-dimensional to 3-dimensional. Any doubt again? Any doubts? Yes. Hmm? Actual scale everywhere you have to convert that. Hmm? Yeah, yes. In your diagram sheet you have to draw this is from the question paper to actual scale to iso scale to iso scale అది 30 degree తీసుకొని అక్కడ పెట్టాలి. Okay, so I will give some of the problems, some of the views. You have to draw your isometric projections. Okay, you can take example of hexagonal pyramid, square pyramid, or different object which is there in your textbook. Okay, so this is the method, and in the textbook this scale conversion is not mentioned. Okay, so you have to follow this method. Yeah, you can disperse, you can go to your practice session. ज्यादा बोलने की जरूरत नहीं ना, समझ में आया नहीं आया? समझ में आया तो नो प्रॉब्लम, अदरवाइज आई विल टेक वन मोर एग्जांपल. समझ में आया? मे बी. Go to your place.